All right, so here we go, number 6. Again, this is from Objective 2 on Chapter 5, Practice A. And we're finding derivatives, okay? So we're going to need the power rule here, the product rule here, the derivative of e to the power rule. And so here we go. When we differentiate this, y prime, b, we take the derivative of x squared, which is 2x, and we leave the other part alone. Plus, then we leave x squared alone, and we multiply that by the derivative of e to the negative x, which is what? E to the negative x times negative 1. Now the directions say no negative exponents, no fractions and fractions, and reduce as far as you can. So this first term, so that I don't have a negative exponent there, I'm going to rewrite it as 2x over e to the positive x. We're all good with that? If you move the power down, it becomes positive, okay? This next term, what, it would be a negative or a minus, right? Because we've got a negative in there. X squared also over e to the x. Okay. And those have common denominators, right? So we might as well combine them. So 2x minus x squared all divided by e to the x. Okay. No reducing possible. Again, each term isn't multiplied by x or 2 or that sort of thing. Okay. Final answer for number 6. Let's go down to our over to number 7. Okay. Number 7, again, lots going on. We've got a product rule right here. We've got the derivative of an inverse cosine, a fairly new rule. We've got a chain rule with a fractional power, lots of stuff. All right. So here we go with y prime for number 7. I'm going to go ahead and differentiate x, which would be 1, and leave the inverse cosine alone. Plus, the product rule says, leave x alone and multiply by the derivative of the inverse cosine of x. All right, this might be where we need our yellow sheet. Okay, look that up on your yellow sheet. What should we write for the derivative of the inverse cosine of x? Would it just be negative 1 over the square root of 1 minus x squared? All right, because again, in the rule, u is just x this time. Okay, and let's see, that takes care of that first product rule. Then we got a minus, and now we're differentiating the square root of the quantity 1 minus x squared. Well, remember that square rooting is the same as the 1/2 power. All right, so when I differentiate that, the half power is going to jump out front. The 1 minus x squared stays the same inside. The power drops by 1 to negative 1/2. And we multiply by the derivative of the inside, which is negative 2x. All right. We have some beautifying to do. Okay. Now, this first inverse cosine, remember that's inverse cosine or arc cosine, so that would not be considered a negative exponent. Okay, so when it says for my directions, no negative exponents, that's really not considered a negative exponent. That's considered an inverse. All right. This term here, what could we simplify that as? Minus x over the square root of 1 minus x squared. Okay. Decide what this big blob of terms simplifies to be. Positive or negative? Positive. And then doesn't this half cancel with that too? But we still have the x. And then no negative exponents, so this negative half power, I'm going to move that quantity on the bottom. All right, and raising something to the half power is the same as square rooting it. right? And aren't these opposites? So those cancel out, and our final answer, inverse cosine, whoops, of x, again, that's the same as the arc cosine of x. Okay. All right, you notice that sometimes in your assignment things happen like that. Oh, wow, it's amazing. You know, that's just how they structure those derivatives sometimes to work out so that that magical stuff happens at the end. Okay. Number 8. Again, I just wrote it on here just to give myself a little more room. Feel free to use other paper for your practice test also. But the directions say find the derivative of the function, and then for B, we're going to find an equation of a tangent line at the point 1, 1. Okay? Again, what makes this harder is we have to differentiate implicitly. The x's and y's are mixed up. Not only that, but we've got new rules in here, our natural log derivative rule, our e to the power derivative rule. Okay? So let's go ahead and find this derivative with respect to x. What happens when you differentiate a constant? 0. All right. The derivative of the natural log of something, though, is 1 over that something. But then we have to multiply by the derivative of the inside. Okay. Kind of complicated because it's a product. So if I differentiate x with respect to x, that's 1, and I leave y alone. Plus, then I leave x alone, and the derivative of y with respect to x is y prime. Again, I would just as soon leave those as 2 parts rather than put this whole thing on top. But that's just, I just think it's easier that way. Okay? So we're done with that side. Move over to the other side. The derivative of e to any power is e to that power. But again, we've got to multiply by the derivative of the power. The derivative of x with respect to x is just 1, minus the derivative of y with respect to x is y prime. Now we have to gather the y primes. All right. Another reason not to make this a fraction, because I'm going to have to split this part off. I'm going to go ahead and distribute this through here. I suppose if we made it one fraction, we could just divide xy into each part. But when I multiply 1 over xy times 1 over y, don't I just get 1 over x? Because the y's cancel. And then 1 over xy times xy prime would be, wouldn't that be y prime over y? And then on this side, I want to distribute also, again, because I'm going to have to get this y prime with the other one. So I want to multiply by this quantity all the way through. E to the x minus y times 1 is just e to the x minus y. E to the x minus y times y prime, I'm going to call that minus y prime e to the x minus y. So now we've got a y prime term on this side and a y prime term on that side. We can get them on either side. It doesn't matter. We talked about that whole positive negative business before. I'm going to go ahead and add this one to this side. Y prime e to the x minus y. I'm going to add that to this one. So it won't be over here anymore. Okay. So here my y primes are together, so I'm going to subtract this 1 over x onto this side also. So minus 1 over x